Hello guys, you welcome to our class. This is Noble My Science Tutors Online, and I remain Otobo Michael. So for our class for today, we are going to be looking at electrical work and power. Electrical work and power. So we have started in our previous class. We treated current electricity and how resistors are connected in parallel and in series. Also, we looked at cells in series and cells in parallel, and we have solved some problems on them. So you can review those classes or those videos, so that in this particular video you'll be referring to some of those equations that were treated in those videos. So you can just review them so that you can flow easily, right? So I've always said, get your writing materials so that we can go straight to our class. But before then, please, if you have not subscribed to this channel, please subscribe to this channel. Click on the notification bell so that whenever we upload a new video, YouTube will notify you. Also, you can reach us via the WhatsApp number that is showing on your screen. Is that okay? That is not all. Please, if you like what we are doing, give us a thumbs up, give us a positive comment, give us a like. Is that okay, to encourage us? Alright, so in Noble My Science Tutors Online, we are bringing physics classes direct to your doorstep. And this channel, all the videos in this channel, all the classes, they are arranged in such a way that it follows the Nigeria curriculum of physics from SS1 to SS3. So if you are a physics student and you are in Nigeria, or you are in all these West African countries, even all over the world, I think the topics are almost like the same. Is that okay? So please just follow through. We have uploaded more than 70 videos in different topics in physics, so you can visit our other videos. Just click on the topic that you want to view if you have treated it, and then go through it, right? And whenever you are viewing the topics or the videos or the lectures, get your writing materials, get your calculator so that you can follow through, solve problems. Because the more problems you solve, the more you have a better understanding and grasp of the principles in physics. Okay, so having said all that, let's go straight to our class for today. I hope you are ready. Okay, so as I said, today we'll be looking at electrical work and power, or electrical energy and power. So this is electrical work. We know that work done normally is that is in normal motion. Work done is force times distance, right? But in electrical power and energy, for electrical work, remember that in our last class we said that potential difference, which is V, is equals to work done all over charge. So this equation, you can also write it as work done is equals to QV. Okay, now when we define current, we said that current I is equals to quantity of charge all over time. So we said that Q is equals to IT, current as time. So if you substitute this quantity of charge, which is current at time, into this equation, you have that work done is equals to IVT. Okay, IVT. So this is the first equation. So depending on the variable you are given, if you are given a question where you have the current, the voltage, and the time, you can find the work done. Okay, you can find the work done. Now, from Ohm's law, we had that V, potential difference, equals to current times resistance. So we can actually put that into the same equation, so that if you substitute this equation, you have that work done is equals to current times current times resistance times time. So that gives you I squared, current squared, times resistance times time. Okay, so I'm just taking the pain to let you know how these equations were derived. Okay, so also from this same equation, also from this particular equation, that is this one, we have that current is equals to V over R. Current is equals to V over R. So you can also substitute this into your equation. You can substitute into this equation, or you can substitute it into this equation, as the case may be. You can substitute into here or here. If you substitute into there, you have that work done will be equals to V squared time all over R. Okay, so any of these equations can be used. Any of these equation 1, 2, and 3, and this particular one can be used to find the work done in an electrical system. Okay, so these are the equations for the work done in an electrical system. All right, so let's go to power, electrical power. Okay, so before we talk about electrical power, we'll still talk about electrical energy. So electrical energy can be converted into heat energy, where heat energy for electrical system, we said that work done is equals to IVT. Heat energy and work done, they are the same, so heat energy is also IVT. So just put all those equations as we got them. Heat energy is equals to I square RT, right? Then you also have this third one, heat energy is equals to V square over R times T. So any of these equations you can be used to find the heat energy generated in an electrical system. Electrical energy can also be converted to mechanical energy in the form of rotation of the blade of a fan. It can be converted to light energy in the glowing filament of lamps, and electrical energy can also be converted to sound energy in telephone earpiece. So these are the various ways or various areas to which electrical energy can be converted, and these are also the equations for the heat energy generated. Okay, so that is it. Take note of these equations. Electrical power, we know that power is equals to energy all over time, or it can be equals to work done all over time. Okay, so if you know that, then from all the equations that we have for work done, we can have that power is equals to QV all over T. Okay, because work done is QV, so power can be equals to QV all over T. QV all over T. Power can also be IVT all over T. So this will cancel out. So power will be equals to IV. Alright, then from the other equation, power can also be I squared RT all over T. So this will cancel out, and then you have that power is equals to I squared R. You see how this equation came about? So the same thing, to power is equals to V squared T all over r times t. So this will cancel out so that your power is equals to v square all over r. If you are saying it, then from this particular equation we have that work done is equals to power times time, or that energy is equals to power times time. So all these equations that are given to you, they are very key. All of them, they are what I have here already. I just do this one for you to understand how all these ones came about. So everything that is here is what is here. Okay, so I did this one so for you to understand. This is this, this is this, this is this, and this is this. Okay, all right, so I hope this is clear and this is understood, right? So that is how to get all those equations. So we already know the meaning of each of these symbols. This is power, this is electrical energy, and this is time. Voltage is potential difference, and arrow is resistance, okay, and Q is quantity of energy. And Q is measured, or quantity of charge, and it's measured in coulomb. Power is measured in watts. Voltage, PD is in voltage, time is in seconds. So it is good you understand all this, right? So I think we'll go straight now and see how we can apply all these equations in solving some problems. But before we solve some problems, there's another area of power that I want you to take note of. Remember, I said that power is equals to energy over time. So energy is equals to power times time. Okay, so if you know that, when you consume energy, like in Nigeria, we have the power holding company that charges, and they charge per energy consumption per the hour. Okay, they charge per energy consumption per hour. So 1 kilowatt hour is the electrical energy consumed by an appliance when power of 1 kilowatt is used by the appliance for 1 hour. So 1 kilowatt is 10 raised to power 3. 1 hour converted to second is 60 times 60. So that gives you 3.6 times 10 to the power 6 joules. So this is the quantity of energy that is consumed in 1 hour. Okay, so assuming you will now have an electric bulb max 60 watt that is put on for 20 hours, the amount of energy that will be consumed will be 60 times 20. That gives you 1.2 kilowatt hour. Now, if energy is charged maybe 10 kobo per kilowatt hour, the total energy consumed when you use this bulb for 10 hours will be equals to 12 kobo. Okay, the total energy consumed when you use this bulb for 12 hours, for 10 hours, will be equals to 12 kobo. Or if we use the bulb for 20 hours, because here it said 20 hours. So if the bulb was used for 20 hours, the total energy consumed will not be 12 kobo, but it will rather be 24 kobo. So depending on what you are working with, but here I use 10 hours, but this is 20 hours. So I think I can make that correction so that energy consumed in 20 hours at the rate of 1 kilowatt for 10 kobo will be 1.2 times 20. So if you do that, you are going to have 24 kobo as the cost of energy per hour. I mean, for the 12 or the 20 hours, that would be the cost of power consumption for 20 hours. Okay, so having known this, we are going to solve problems that will make this to be very clear for you to understand. Right, so let's go straight and solve some problems. Okay, so this is a sample question that I want us to solve. This is a sample question that I want us to solve. Alright, so this one says that calculate the resistance of a filament lamp rated 240 volts, 40 watts. It's a wire question. Now, what this means is that the power of the filament or the power consumed is 40 watts, or the power generator is 40 watts when 240 volts is delivered through the filament. So this is the power consumption. So they say calculate the resistance. So when you look at all the equations, which of them relates power to resistance and to voltage? So we had how many equations there? We had about 3 equations, right? So we had that power is equals to IV. Another one we had power is equals to I square R. We also had that power is equals to V squared all over R. So amongst this equation, which of them are you supposed to use? I think it is this one, right? So you say power is equals to V squared all over R. Because this is the only equation that relates power to voltage and to resistance, and you are looking for resistance. All right, so you now make your resistance the subject of the formula, so that you have V squared all over power. Substituting into this equation, you have 240 volts times 240 all over 40. Okay, so by the time you multiply this out, you are going to have, you will have, when you do that division, you are going to have 1440 ohm as your answer. Okay, so I hope that one is simple to apply. But what you need to do is to try to remember all the equations. You see the way I brought them out, so I can easily pick the one that relates the variables that I'm giving in this particular question. Is that okay? So let's also look at this one. Say a 12 ohm resistor dissipates 8 kilojoule of heat in 20 seconds. Calculate the current flowing through the resistor. Okay, so in this particular question, you are given resistance, you are given the heat energy generated, and then you're given the time. So we remember that we had a heat energy H is equals to what? IVT is equals to I square RT is also equals to what? V square T all over R. So we had all these equations. We remember. Okay, so if you look at the variables you are giving resistance, you are giving heat energy, you are also giving time. Now you are asked to calculate the current that is flowing. So which of this equation applies? I think it should be this. Okay, so if this, then convert your heat energy to joules. That means you want multiplying this one by 1000. So 8 kilojoule multiplied by 1000, we convert that one to 8000 joules. Okay, so substituting into this equation, which is equals to your H, so you have that 8000 is equals to I squared multiplied by 12, which is your resistance, times time, which is 20. So you make your I squared the subject of the formula. So that gives you 8,000 divided by 12 times 20. Okay, so by the time you make that your division out, you are going to have 66.67. and purge that from your calculator. Then I will be the square root of that, will be the square root of 66.67, and that gives us, from your calculator, that gives us 8.16 amp. 8.16 amp. So what I want you to take note of is how I'm using the formulas. You saw the way I brought out the formulas, then I look at the variables that are given to me so that I will know which of them to use. Okay, so you can do it like so that it will be simpler for you to understand. So once you remember this formula, it becomes very easy for you to apply and then to solve any problem that you need to solve. Alright, so this will be your answer, and this is how I went. I'm not after the answer. What I'm after is your understanding of how we got to this level and how we apply these equations. That's okay. So once you understand this, even if you are asleep, you can solve any problem. Okay, so let's go to another one. Okay, so this is another question that we also need to look at. It says that an electric kettle connected to a 240 volt mains produces 6.0 times 10 raised by 5 joule of heat energy to boil a quantity of water in 5 minutes. Find the resistance of the kettle. Okay, so just as we did before, they are giving you the voltage that it's connected to, the heat energy, and then time. It says you find resistance. Okay, so you look at the question and look at what is given to you. There is a jam question. So heat energy is equals to what? IVT. It is equals to I square RT. It is also equals to V square T all over R. Okay, so here we are giving V to be 240 volts. We are giving H to be equals to 6 times 0 times 10 raised to power 5 joule. You are giving time to be equals to 55 minutes. You convert that to second, multiply by 60. Fine. So here they are asked to find resistance. So which of these equations now 1, 2, 3 applies? I think it should be the third one. So this one applies. So taking that one, so write that H, heat energy, is equals to V squared all times time all over resistance. So we'll make arrow the subject so that we'll have V squared times T all over H. So we substitute into this equation. V is 240, so that will be 240 times 240 times 5 times 60. Remember, we're converting minutes to second, all over 6.0 times 10 raised to power 5 joule. Okay, so you can punch all this out in your calculator. So you have that arrow is equals to, when you punch everything out from your calculator. Okay, you have an R is equals to 28.8 ohm. This is what you are going to have, 28.8 ohm by the time you puncture this in your calculator. So that's okay. So basically what you should understand is how to bring out these equations and then how to apply them. How to apply, knowing which of the equations to use based on the variable that you are given, so that you can apply it and solve your problems, and then you have your answer comes out readily. This is another question. This is another question. Here said calculate the rate of energy consumption, that is 1. The total heat energy developed in 15 minutes in the circuit illustrated by the diagram below. So you are going to calculate the rate of energy consumption. You know that rate is equivalent to power. So when you talk about rate of energy consumption, it means that you're asking you to find the power. Is that okay? It means that they are asking you to find the power. So that is what the rate of energy consumption means. So what we are going to do first of all here is to find the overall resistance of this arrangement. These resistors are arranged in parallel. So you first of all find their overall resistance. Okay, so once you are able to know the overall resistance, you already know the current that is given to you. You now know the equations to apply. So the overall resistances are in parallel. You have that 1 over R, is equals to 1 over 4 plus 1 over 4. So this gives us 2 over 4. So R is equals to equals to 2 ohm. Please, this is simple this thing that you don't need to ask me how I got it to, right? Okay, so this is your R now. Now they say you should find rate. Rate is power. So which of those equations for the number one is find rate of energy consumption, which is power. Okay, so power we said is equals to IV is equals to I squared R is equals to V squared all over R. So amongst these, this is the equation that can apply. So while the power, which is the rate of energy consumption, is equals to I squared times R. Okay, so you can just do that multiplication. You have I is given to you is 2.5. This is your I, this is the current. That is the current. 2.5 times 2.5 multiplied by the resistance, which is 2. So if you work all that out, you are going to have 12.5 watts. You have 12.5 watts. Then the next one is the total energy, the total heat energy developed in 15 minutes in the circuit illustrated by in the diagram below. So the heat energy is equals to power times time. Okay, heat energy is power times time. So just substitute that. So you have 12.5, which is your power, multiplied by time. Time is 15 minutes. Convert it to seconds. Okay, so by the time you multiply all this out, you are going to have 1125 joule as the heat energy consumed, or as the heat energy developed. Okay, so if you look at it, you see the way we went about solving this problem. Okay, first of all, finding the overall resistance, then knowing that rate has to do with power, then knowing the equations to use, which we selected, substituting variables to get your answers. So I hope this one is clear and it is also simple for you to understand. Alright, so we still have other questions to solve. I need to solve some sizable numbers of questions just to drive home the topic so that you understand it better. Alright, these are other sample questions that I also want to look into. While I'm solving all this problem is I'm trying to make sure that I go around all the topics so that you understand better. Okay, fine. So this one says, the first question says, an electric appliance takes 5 amp when operated on a 220 volt supply. Find the cost of operating the appliance for 12 hours at 10 kobo per kilowatt hour. Okay, so what you are going to do first of all in this equation is for you to find the power. Okay, so when you know the power, you will now calculate the energy consumed. Once you know the energy consumed, you can now calculate the cost of that energy, because what is charged at home in your electrical meter, whatever it is, the energy that you consume, right? So for you here, you are giving current, you are giving voltage. So power is equals to IV. Okay, so your power is, if you substitute that, to be 5 times 220 volts. Now energy consumed is equals to power times time. So this will be equals to 5 times 220 times the time, and the time here is 12 hours. The time here is 12 hours. So that is it. So what you now do is that you multiply everything out. You multiply everything out. So by the time you multiply everything out here, you are going to have 13,200 watts per hour. So if you convert this one to kilowatt hour, in kilowatt hour you divide by 1000. Divide this by 1000 to convert it to kilowatt hour. Okay, so if you do that, you are going to have that energy consumption is 13.2 kilowatts hour. So that is the energy consumption. Now if the cost of 1 kilowatt hour is equals to, so now if 1 kilowatt hour is equals to 10 kobo, 13.2 kilowatt hour will be equals to 13.2 kilowatt hour will be equals to 13.2 kilowatt hour all over kilowatt hour multiplied by 10. Okay, so this times 10 kobo. So all this cancels out, so that you now have your cost of energy will be 132 kobo. Okay, if you convert this to naira, it will be equals to 1 naira 32 kobo. 1 naira 32 kobo. Okay, so this is how to calculate the cost of energy consumption. You first of all calculate the energy consumed, which is power times time, then multiply it by the cost of the energy. Cost of energy is 10 kobo per kilowatt hour. So by the time you multiply it, you will have the cost or the amount of that you pay for your energy that you consume. Is that okay? Alright, so let's do the second one here. This one say an electric lamp is rated 240 volts and 40 watts. What is the cost of running the lamp for 72 hours if the electricity charge is 2 naira 50 kobo per kilowatt hour? So just like we did for the other one, that's also what we are going to do. Here you are given the power already, and this is the time. Then this is the cost of energy per kilowatt hour. So what we need to do here is that we'll calculate we already have the power, so energy consumption is equals to power times time. Okay, so that gives us 40 multiplied by 72. That will give you the energy consumption. So if you do that multiplication, you are going to have 2,880 watts per hour. Okay, so if you convert it to kilowatt hour, to be, you divide it by 1000 divided by 1000, you have 2.880 kilowatts hour. Okay, so now you have known the energy consumption, but what is the cost of this energy that you consume? We are told here that 1 kilowatt hour is equals to 1 kilowatt hour is equals to 2 naira 50 kobo. Okay, so 2.880 kilowatt hour will be equals to how much? To be equals to 2.880 kilowatt hour all over 1 kilowatt hour multiplied by 2 naira 50 kobo. Okay, so by the time you multiply this one out, you are going to have that the cost of electricity will be equals to 7 naira 20 kobo. Okay, so that will be the cost of your electricity. So if you look at these two questions now, you see that first of all you calculate the energy consumed, which is power times time. So in case you are not giving power here, you calculate it, but here you were giving the power, so you don't need to use this voltage again. You just multiply the power times time, which is give you your energy consumption, then do your calculation to get the cost of the energy that you consume. Okay, so I hope this one is clear for you too. So let's do lastly, let's solve this one. So I hope that we've solved a lot of problems on this, so and I hope you have followed through. Okay, so this one, a potential difference of 10 volts is applied across the ends of a 6 ohm resistor for 10 minutes. Determine the quantity of heat generated. So I think this one is simple. Heat energy is equals to IVT, or it is equals to I square RT is equals to V square T all over R. So in among these three equations, the one that applies is this one. Okay, so this is the one that applies. So you just substitute to that equation where that H is equals to V square T all over R. That gives you 12 times 12 times 10 times 60 all over 6. Okay, all over 6. So by the time you calculate that one out, so if you work this out, you are going to have 14,400 joules. Okay, so that is how to solve this problem. Alright guys, I hope you have learned a lot. So let's go to your test page. Alright, so this is test your understanding page. All the questions that were solved, they are here. So your own is to relate to all the questions that we solve and use those examples to solve these problems. Alright, just relate to them and then solve all these problems. If you have any challenge, you can reach us. Okay, so thank you guys. This is where we are stopping our class for today. Thank you so much for your time. But before I leave, please guys, if you like what we're doing, please subscribe to our channel, give us a like, give us a thumbs up, and also give us a positive comment to encourage us. Is that okay? So this is Normal Science Tutors Online. I remain Otoro Mike. I wish you a very wonderful time studying physics, and then we hope to see you in our next class. Thanks so much.